Podcast. This is Mr. White.
And Mr. Sadler.
And what you have here is the picture of a silly man. And he is doing a lot of work. And so, Mr. Sadler, go ahead and refresh my memory. What is work?
Force over a distance.
So, force times some distance. And we have spent a lot of time talking about that, but we have not gone into one of the very key conditions for force and distance to do work. And that condition is very simple. The force must be parallel to the distance traveled. So what if force were perpendicular to the distance?
Well, then it can't be work, can it? Because it's like.
Well, let me ask this question. So this guy here, he is applying a force. Okay, that is up and to the right, just a little bit, but
Correct.
Mostly to the right.
Correct.
Okay, there is this, so we'll call that the applied force. And then there's this frictional force, which is directed that way.
Correct.
And there is this large normal force pointing up, and there's this weight force pointing down. Those are all true things, right?
Correct.
Now, the applied force, the gravitational force, is the gravitational force doing any work?
No.
Because it's perpendicular to the right, which is the direction the bus is traveling.
Correct.
Is the normal force doing any work?
No.
Because it's perpendicular to
Well,
the
there
right.
really is no net force in that direction.
Correct. And that's another thing to point out. When we say force, we're talking about the net force. It's friction doing work.
Absolutely.
Right.
Otherwise, you'd be coasting.
Yeah, otherwise this would have been easy. And then the good question is, am I doing work?
Absolutely.
Now here's a better question. Is all of my force doing work?
No.
No, it's not. And that is the tragedy here. A good part of my applied force is doing work, but some of my applied force is trying to do what?
Lift the bus.
Yeah.
That's awesome.
The bus has a mass of about 12,500
Right.
pounds, and I don't eat enough Wheaties to
Right.
pull that off. Do they know what Wheaties are?
I hope so.
I hope so. So unfortunately, some of my force is trying to pull the bus up off of the ground. So if I were to get rid of all of this, and I were to apply a force that was straight up, the bus wouldn't go anywhere.
Correct.
If I were to apply a force at a larger angle, it's likely that the bus wouldn't go anywhere because too much of my force
Is spent lifting rather than pulling.
right. And so this would be a very futile exercise. So in this diagram, what we're trying to show is that I needed to get lower. Because I wasn't low enough, this was harder than it needed to be. And so if I could have applied a force that was parallel to the ground, and I took this angle out of it, I would be doing more work to move the bus and less failed work to lift the bus off the ground. Is that
Right.
That seems right. Could I be going, is it possible I could go too low?
Well, I would think that if you crouch too low, you would have the same angle. But I think the reason that you're attempting to lift the bus here is because I think if you get much lower, it's going to be more difficult because you don't want your knees scraping the ground or something like that.
Right. But if theoretically, let's say I pulled a yellow bus, it would have been easier for me to get parallel to the ground. But then I could have introduced this problem
Just
where I
the
was
opposite.
pulling down, and so if this is parallel here, by pulling down, I'd actually be pulling the bus into the ground, and,
Right.
and doing
I think that might be futile also.
that would also be frustrating. Yeah. So there's all kinds of interesting things that come out of this. This was the byproduct of a student challenge several years ago. We were talking about the world's strongest man. and we were relating work to power. And so we were talking about, okay, is the world's strongest man, should it be called the world's most powerful man? And I indicated that, well, I could pull a bus because that's something that I've seen these guys do on several occasions. And the kid said, well, there's no way you can pull the bus. I can pull the bus, but what I can't do is I can't do it quickly. So I would not qualify for the world's most powerful man. I am, unfortunately, capable of doing some pretty silly things, but I can't do it quickly. And if you watch that show, they do stuff like this. And so that's what's going on here. So how does that work? I want to say this one more time. To do work, the force must be what?
Parallel.
Parallel to the displacement. And if it's not, some or all of your force is going to not be working out too well. There's a lot of physics that goes on in that World's Strongest Man competition. So we're going to leave you with me pulling the bus. I wish we had used a tripod. Something tells me someday I'll end up doing this again, one more time. And go ahead and take a look at that. We turned this into a podcast for our students last year, but we never brought it up until Chapter 4 this year. So I believe that covers it. Signing off, this is Mr. White.
And Mr. Sadler. Moving.
Definitely hitting an incline here.
That's it.